Hello, my name is Dom Scrivano, and today I'm going to be demonstrating an application of Bernoulli's equation. For my demonstration, I will be showing how a siphon system works using a few household items: 2 glasses, an empty water bottle, a rubber tube, and the top of this water bottle hot glued to it. Alright, so to start, I'm going to keep this full glass at a higher elevation than this glass, and I'll explain why later. But just for demonstration purposes, I'm going to put this end of the tube in the full glass. But notice how nothing happens when I put it in here. Even if I put this down here in this glass, nothing changes. That's because in both glasses, the same amount of pressure is being induced through this tube. So there's atmospheric pressure pushing down on top of this liquid, which you can kind of see in the tube. The liquid rises up to where they both intersect. And in this tube, there's atmospheric pressure pushing down through all the way to here. So essentially right now it's at equilibrium. Now I'm going to create a vacuum. And essentially the point of that is I'm reducing the pressure inside this tube to be a value that's less than the value of atmospheric pressure, which is 14.7 psi. So when I squeeze this bottle, I'm taking the air pressure out of the tube, and that is going to result in the liquid following it to this cup. So I'll do that now. Okay, I started the process, and now I'm going to transfer it to this cup. Okay, so now we have steady flow. And notice how this line is reducing. That's because liquid or fluid has a natural tendency to flow from places of high pressure to low pressure. So this process will continue until the cup is either empty or the liquid levels reach the same elevation. So the way I have it set up now, this cup is going to empty. But to prevent that, I can move it back down. And now we can see this one's going to flow to a place of low pressure. And this will occur until both liquid levels, again, they reach the same height. The fluid in the left cup is going up and the fluid in the right cup is going down. This is because the fluid is trying to reach its equilibrium state, having pressure on both sides be the same. They look pretty much the same. And now, to move it back up, you can see this fluid's decreasing and this one's increasing. And again, that's because all I'm doing here is changing the potential energy between the 2 cups in the system. And you see atmospheric pressure pushing down. So here's Bernoulli's equation, and here's a drawing of the setup that we did earlier. In this equation, P equals pressure, V equals velocity, Z equals elevation, G equals gravitational acceleration, and gamma equals specific weight of the fluid. So after some simplification under some assumptions, we get that potential equals kinetic energy. That's the relationship that we're trying to display here. The reason I assume these to be 0 is because atmospheric pressure, when measured relative to gauge, is 0. Velocity at the top is 0. And then pressure 2 is also atmospheric, so it's 0. You simplify, you get this equation here. V equals the square root of 2gh, which makes sense because the reason that we have flow and the reason there's velocity here is because we're giving the top cup potential energy. On the flip side, when I put the cup down flat, when they're at the same elevation, you can see that they both rise and stop at their equilibrium point. That's because I'm eliminating this height factor, resulting in the velocity going to 0. Here the cups are at the same elevation and it can be seen that the fluid levels are equivalent, so the system has reached equilibrium. When I lift the right cup, I increase the potential energy, causing a velocity of the fluid in the tube. The less filled cup begins to fill. Once I return the cups to the same elevation, the fluid from the higher cup will flow into the cup with less fluid until equilibrium is reached once again. This is because the pressure on the fluid is equivalent in both cups, being 14.7 psi or atmospheric pressure. So to wrap everything up, Bernoulli's equation is extremely important in fluid mechanics because it helps us understand flow and how pressure, velocity, and elevation changes affect it. Thank you for watching my video. I hope you enjoyed it.